Greetings once again. Thanks for taking the time to watch another one of my videos. I would like to spend time with you today talking about the quotient rule, which tells us how to take derivatives of quotients, where a quotient is a thing that looks like f over g. So when we happen to be out in the world and all of a sudden a new function pops up and we'd like to take its derivative, as so often happens in my life, and the function that pops up, I'm like, oh, this is a ratio of two functions that I already knew how to take the derivatives of. I apply the quotient rule. So in the case that I find I have a ratio like this, the quotient rule tells me that h prime, I'm going to suppress the of x's here because there's just way too much of x. H prime, the derivative of this quotient right here, is, I think I'm going to rewrite that as f over g a bit more over. F over g. I'm going to go low d high, so I'm going to go g times f prime minus high d low, draw a line, and square below. I'm not going to give you justification for why this rule is true right now. Rest assured, however, that it is most assuredly not equal to f prime over g prime. Look how different these things are. These things are so super different, it's ridiculous. So don't get sucked into this trap, because there are scary monsters down that hole. And I'm pretty sure that they have big nasty teeth, and they will eat us. So I'm going to erase that doubly so that we can't possibly accidentally use that later on. So I want to give you a little is it a mnemonic device? So I'm going to go, so this is low. G is the low one, low. And this one is high, because it's on top. So it goes low d high, where the d is for derivative. Low d high minus high d low. Draw a line and square below. It's like a square dancing thing. I'm not going to sing it right now, but rest assured you can sing it, and you should totally sing it. Like, you should sing this to yourself, like, right now. Like, isn't that fun? It's not going to make it to the top of the charts, and I'm pretty sure that Bieber's never going to sing it, but it's still true, and it's a good device for remembering the quotient rule. Let's do an example. So let's take our function h to be equal to e to the x over 4x plus 4. I do not want to use the definition of the derivative with the limit as h goes to 0 of f of x plus h minus f of x all over h. There's no way that I'm going to do that to this thing. I'm going to use the quotient rule. So this part right here is going to be my f. This part down here is going to be my g. And I'm going to apply the quotient rule. So h prime is equal to, let's see here, so I'm going to go low, 4x plus 4 times d high, derivative of e to the x is e to the x, minus high, e to the x, d low is 4, because it's just a line, so I pick up the slope. Slope of the tangent line to a line is just the slope of the line. Draw a line, and square below. And I'm done. Depending on how done you really want to be. Should we simplify it one level? I kind of want to. I don't know, I kind of don't want to also. So let's do it once. So let's pull an e to the x out of that. So I have e to the x. So I pulled it out of both of those. Ooh, I can take a 4 out also. So I'm going to have 4. And then I get x plus 1 minus 1. Oh, sweet. That means I get to just write 4x, 4e to the x. Wicked. all over 4x plus 4 squared. Seems good. I don't know if we want to, like, distribute that thing out. Probably not. We could, like, cancel the 4. I don't know. I think I'm going to be good on that one. Let's do another one. Okay, so that was low D high minus high D low. Draw a line and square below. So let's set ourselves up again. Let's do a new function. Sometimes these ones with e to the x's can be a little misleading because the derivative of e to the x is e to the x. Right? So it's its own derivative, and so it can be hard to tell, like, did I take the derivative of that thing? So for this next one here, let's not use any e to the x in it. I'm going to leave that horizontal bar in line. Excuse me. Because I think we're going to need it. Alrighty. Let's do a quotient. Let's go like that. And in the bottom, let's go the square root of x plus x cubed. And the numerator, let's try 1 plus x to the 4/3 minus, I don't know, I like square root of x. Square root of x is fun. Alrighty. We want to take the derivative of this thing. We're going to do it using the quotient rule. So I've got my top function, my bottom function. So I'm going to go low D high. I think I'm going to run off screen if I do it like this. So h prime is equal to, I'm going to go low D high. So the first thing I'm going to do is leave the low alone, and I'm going to be all like root x plus x cubed times derivative of the high. Derivative of 1 is 0, so I'm not going to write it. 4/3 x to the 1/3, that's the derivative of that term, minus a half of x to the minus a half. Oh yeah, there's no way that was going to fit on the screen. Minus, oh, the spacing is going to be absolutely atrocious here. All over the bottom here. Okay, so let's do D low. There's no way I should have written that yet either. See, this is why you should, like, write in pencil or, like, have lots of paper available to you. Because spacing can be a problem. So let's take the derivative of this thing right here. So we're going to get a half of x to the minus a half plus 3x squared times, now I'm going to put this one without modifying it. 1 plus x to the 4/3 minus root x. Okay, draw a line and square below. Root x plus x cubed squared. And we're done. I mean, we should probably simplify, and the simplification is going to take a while. I don't see anything like super obvious that's going to happen. Definitely, we're going to get some, like, 6th roots up in here, which is probably not going to be a whole lot of usefulness as far as simplifying stuff. Yeah, I don't think I want to simplify that. I think I'm going to call it good on that. I think this video was more about the, like, low D high minus high D low, draw a line and square below than it is about simplification, so I think I'm going to stop there. This whole thing here is the numerator. It's very long, and that's the way it is. Okay, quotient rule. Low D high minus high D low, draw a line and square below. Yeah. Thanks for watching. Good luck with your quotienting and your producting and your powering and all of the other things that you can do with functions and taking derivatives of those things. I wish you all the best today. Bye.